Okay, I need somebody to confirm this morning that you are able to see the shared screen.
Yes, sir.
Yes, sir.
Okay, great, great. Thank you very much. Okay, so we are going to get started right away. With a quick recap, very quick recap of what we did last time. So recap from last time. So last time we learned about a few counting methods, counting principles. And the reason that we wanted to do these counting methods, learn these counting methods was in many of the probability questions, you run into a situation when you cannot manually count everything. You have to have some sort of tools available to you to help you do the counting. And we learned about a few counting principles. One was the basic counting principle. And the basic counting principle said that if there is one experiment, so first experiment that can result in m possible outcomes. So for example, if it is rolling a dice, there are 6 possible outcomes. If it is tossing a coin, there are 2 possible outcomes. And then you also have a second experiment. And the second experiment has n possible outcomes. If you perform both of these experiments together, perform both of these experiments together, total m times n possible outcomes. So this was the very basic counting principle. Then we talked about permutations. And what is permutations? Permutations is the total number of different arrangement of objects. So you have n objects, okay? And permutation is simply number of different arrangements of these objects. If objects are unique objects, if all the objects are unique, then you have n factorial ways of arranging these, or n factorial arrangements, or n factorial permutations. All of these terminologies used. So n factorial ways or permutations or arrangements or different arrangements of making sure that those arrangements that you get, they are all unique, they are all different from each other. Okay, so A, B, C is different from C, B, A, and so on and so forth. If there are non-unique objects, if some objects are not unique, if some objects are non-unique, so ऐसा हो सकता है कि total n objects, out of which n1 of first type, n2 of second type, etc., nr of rth type. Okay, then you have number of different arrangements or number of permutations, unique permutations. Now this is not going to be equal to n factorial. Why? Because there are n1 objects of first type. ये हमारे पास इसकी एक एग्जांपल थी A, B, C, A. So A is repeated here, which means this A, B, C, A is the same as A, B, C, A, which is the second A coming first and the first A coming last. So A, B, C, A, you cannot have four factorial possible arrangement. So you need to make sure that you reduce this count by whatever you are double counting, and whatever you are double counting is there are two A's which themselves can be arranged in 2 factorial ways. So that would be 2 factorial divided by 2 factorial, and in the general case divided by n1 factorial, and then n2 factorial, and so on and so forth, and r factorial. This is the total number of permutations. Okay, and we had a couple of examples. So one example of this is we have this word assassin. How many total permutations? Answers in the chat window. How many total permutations for this word assassin, for all these letters A, S, S, A, S, S, I, N? How many total different permutations? Answers in the chat window. Anyone? Yeah. So there are 8 letters here, 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8 factorial, but we are overcounting. We are overcounting. Why? Because there are 2 A's here, 2 A's here. So I need to divide by 2 factorial. There are also 4 S here, and the letter S is repeated 4 times. So I should divide by 4 factorial. And then I is repeated 1 time. You can divide by 1 factorial, which is 1, and N is also 1 time, which is again 1 factorial. But there is no need to write that. Okay. So this is great. This is great. So now we know about basic counting principle. We also know about permutations, and then we also talked about combinations. Combinations. And what is combinations? Combinations is if you have n objects, and you pick a subset of those objects. Pick R objects. R smaller than n, smaller than or equal to n. Of course, if R is equal to n, then there is only one way of picking all of those objects. There is only one way. So n choose R is the total number of ways you can pick R objects out of those n objects. So number of ways of doing this thing, of picking the R objects out of these n objects. Number of ways of picking R objects from n is called NCR or N choose R, different notations. And this is really equal to n factorial over R factorial, n minus R factorial. We did this last time as well. Now, remember that when you are picking these R objects, you are basically making a subcommittee. You have a big number of, pool of objects available. From that big pool of objects, you are picking up a small committee, Okay. And this committee in itself, if you pick a committee of 3 people, within that committee, the number of permutations, we don't need to worry about that because a committee is just a committee. However, if we say that each of the members of the committee is for a specific position, then we can multiply with the number of permutations. There is a couple of examples in the notes that I'm going to upload today right away after the class. You should be able to take a look at that. Okay, and all of these counting methods, counting principles are from very basic, probability that you may have seen in high school, and if not, then may have seen in an earlier undergraduate course. It is a good idea to just revise those, go over a few problems. It will take you probably half an hour to just revise those and do some problems and, just get over with it. Okay. Now, the reason that we went into this counting business is because there were some there were some questions about probability for which we needed to answer this. And if you recall from last time, we considered an antenna problem. There are 4 antennas, 2 good antennas, 2 bad antennas, and you place those antennas on a device. What is the probability the device is working? The device works if no 2 bad antennas are next to each other. If the bad antennas are next to each other, the device will not work. If they are not next to each other or not adjacent to each other, then the device will work. So in that case, we did a manual counting, and manual counting was able to tell us what is the probability that the device would work. But we could not manually count if there were 70 antennas, out of which 15 are faulty. The counting would just take, would not be just possible human. So we needed a basic counting mechanism, permutations, combinations, or a mix of these, and then find the probability. So I will give you an example before moving forward, how the counting problems are related to probability. And again, this example is something which would be included in the notes which I will upload after the class. So how are the counting problems? How are counting problems related to probability? Okay, we have still not talked about a very good concrete definition of probability, but we will do that hopefully by the end of today, or maybe in the early next lecture. Okay, so we'll give you an example here. So the example is, let's say you have 5 women and 3 men. 7 men, sorry, and 7 men. So total of 12 people. Total of 12 people. So I'm going to ask you a few questions. So the first question is, pick a committee of 5. ये 12 लोग हैं, उसमें से 5 की कमेटी पिक करनी है. So out of these 5 plus 7, 12 people, I have to pick a subset, a subcommittee of 5 people. How many ways? How many ways? Answers in the chat window. How many ways? Answers in the chat window. 12C5, 12C5, 12 choose 5. And this turns out to be 792. 12 factorial divided by 5 factorial divided by 7 factorial. This turns out to be 792. Okay. The second thing that I'm going to ask about the same problem, about the same situation, 5 women and 7 men. Okay, so I need to pick a committee of 5. Pick a committee of 5 with 2 women and 3 men. 2 women and 3 men. How many ways? How many ways? How many ways? Answers in the chat window. Answers in the chat window. 3 people have answered, 4 people have answered. Others? 5 लोगों की एक कमेटी बनानी है आपने. 5 women हैं, 7 men हैं. Out of these, I have to pick 2 women and 3 men. How many different ways I can do that? Well, if you think about it, there are 5 women and I have to pick 2 women out of those 5. How many different ways of picking 2 women out of 5? Out of 5, you can pick 2 women in 5 factorial 2 ways. 5 choose 2 ways. 5 choose 2 ways. But that's only picking the number of women. Okay. How many ways I can pick 3 men out of a total of 7 men? 7 में से 3 लोग कैसे पिक करेंगे? 7 में से 3 ऐसे पिक करेंगे. And now looking at the basic counting principle, 5 choose 2 ways of picking 2 women out of 5, and 7 choose 3 ways of picking 3 men out of 7. The 2 experiments, 2 different number of outcomes. Both of these experiments perform together. What is the total number of outcomes? The total number of outcomes is just their product. Basic counting principle है. And this number turns out to be 350. 350. Now, if I ask you that you have these 5 women and 7 men and pick a committee, what is the probability? What is the probability that that committee has 2 women and 3 men? What is the probability the committee will have 2 women and 3 men? Answers in the chat window. Answers in the chat window. So 350 over 792. There are 350 ways of this thing happening. 350 ways of this thing happening that you will pick 2 women and 3 men. 350 different ways of doing so. But there is a 792 ways of picking any 5 people. It could all be 5 men, could be all 5 women, could be 4 men, 1 woman, could be 4 women, 1 man. Okay. So there are 350 ways of picking a committee with 2 women and 3 men, and 792 ways of picking any 5 people. So the chances that you will pick a committee which will have 2 women out of 3 men is 350 such committees out of a total of 792 committees. So the chances that you will pick something which comprises 2 women and 3 men is 350 divided by 792. Somebody had a question? किसी का question था? No question? Okay. So I'm not going to write that here. It's in the notes, but I'm going to ask a slightly different question. I'm going to ask a slightly different question. Okay. And I'm saying that pick a committee of 2 women and 3 men, 2 women and 3 men. Again, it's 5 people. Okay. But we have to pick this committee of 5 people, 2 specific men, they are fighting. They don't like to be on the same committee. These 2 men are fighting. These 2 specific men don't want to be on the committee simultaneously. Don't want to be on the committee together. एक साथ वो कमेटी पे नहीं होना चाहते. उन दोनों में से अगर कोई एक आ जाए, it's okay, it's valid. अगर दोनों ही नहीं आते, it's also okay. It's also okay. So how do you calculate how many different committees can you pick? Now this might look tricky. But we can use a divide and conquer method here. And the divide and conquer method here is कि ऐसा करते हैं कि let's pick 3 men. Let's pick 3 men excluding both the fighters. ये 2 लोग जो आपस में लड़ रहे थे, दोनों को बाहर बिठा देते हैं. Excluding both fighters. I'm using the word fighters a little bit more liberally, but really they didn't want to be on the committee together. So I don't know what else to call them. They are fighters with each other. So pick 3 men. Pick 3 men out of a total of 7 men. Remember, we have total of 7 men. So out of those 7, I have to pick 3, but I need to exclude those 2 fighters. How many different ways of picking 3 men out of a total of 7, excluding those fighters? तो ऐसा करते हैं, 7 में से उन 2 fighters को निकाल देते हैं. 7 जो men हैं, उनमें से दोनों fighters को निकाल दिए. कितने बच गए? 5. And then out of those 5, I pick 3 guys. You 5 choose 3 ways of picking 3 men which exclude both the fighters. Okay. So this is not the answer to our question that pick 2 women and 3 men such that 2 specific men don't want to be on the committee together. ठीक है. ये तो अभी हमने उसका एक बहुत छोटा सा part calculate किया. ठीक है. So this is picking up 3 men, a small committee of 3 men out of a total of 7 men, excluding the 2 fighters. Okay. So second part is again pick 3 men. Remember, हमने 3 लोग ही pick करने हैं. Pick 2 women and 3 men. हमने 3 लोग पिक करने हैं, पिक 3 men, ठीक है, such that 2 men from non-fighters प्लस 1 फाइटर, एक फाइटर को भी ले आते हैं, दोनों फाइटर नहीं लेकर आ सकते, दोनों फाइटर नहीं लेकर आ सकते क्योंकि they refuse to serve on a committee. So this will give you the number of committees, that you can pick from the men only. Out of these 7 people, you exclude both the fighters and then include 1. Okay? So excluding the fighters, out of those 7 people, I have just 5 people. Out of those 5 people, I will pick 2. And then the 2 fighters, I will pick 1 fighter out of those 2 fighters. So 7 लोगों में से 5 ऐसे हैं जो लड़ाई नहीं करते और 2 ऐसे हैं जो लड़ाई करते हैं. जो 5 जो लड़ाई नहीं करते उनमें से मैं 2 पिक कर लेता हूँ और जो 2 लड़ाई करते हैं उनमें से मैं 1 पिक कर लेता हूँ. And you know, 5 choose 2 ways of picking 2 non-fighters from 5 non-fighters multiplied because of the basic counting principle. Out of the 2 fighters, I will pick exactly 1 fighter. So this is going to be 10 ways, and this is going to be 20 ways. 20 ways. Okay. We are still not done yet. Now we have to pick the women as well. Okay. So you pick 2 women out of 5. Pick 2 women out of 5. Remember, we had a total of 5 women. So out of those 5, we have to pick 2. So this would be 5 choose 2 ways, which is equal to 10 ways. Notice that 5 choose 3 and 5 choose 2, both are exactly the same numbers, 10 ways. Why? Because 5 में से 3 को आपने अगर चूज कर लिया है तो जो 2 रह गए हैं यूं समझ लें कि उनका दूसरा ग्रुप बना दिया. सो 5 में से 3 का ग्रुप बना रहे हैं तो 2 वाला छोड़ भी रहे हैं. So 5 choose 3 is the same as 5 choose 2. So now you have picked 2 women out of a total of 5. Now what is our final answer? You picked 2 women and 3 men such that 2 specific men don't want to be on the committee together. What would be our answer? Required answer would be this guy, A plus B, and this whole multiplied by C. इसमें हमने फाइटर्स को एक्सक्लूड कर दिया है, इसमें एक फाइटर को लेकर आई हैं, और this is the number of ways of picking men such that you can include at most 1 fighter, either no fighter or exactly 1 fighter, and then add those number of ways together, because we can add these number of ways because there is no double counting here. या हम वो एक फाइटर इंक्लूड कर रहे हैं या कोई फाइटर इंक्लूड नहीं कर रहे हैं. Exactly 1 fighter and exactly 0 fighter, I can add these up together. This is the total number of ways of picking 3 men out of 7 such that you have no more than 1 fighter on those picked 3 people. And multiply by that with the number of ways you can pick 2 women out of 5, and then you get the answer. And this answer will turn out to be, this is 10 plus 20 times 10. And this would be 300. So let us call this, okay, 2 specific men don't want to be on the committee. Let's call this a valid committee. इसकी हमने डेफिनेशन ही रख दी है, इसका नाम ही है वैलिड कमेटी. सो एक कमेटी जब वैलिड होगी जब उसमें 5 लोग हैं, 2 women and 3 men, and then out of those 2 fighters you have no more than 1 guy. Either none of those are here or only one of those guys is here. Okay, so let us say that this is a valid committee. So now I am going to ask one more thing. So I have asked 3 things here. I'm going to ask one more thing, actually maybe 2 or 3 more things. Okay, now from 5 women and 7 men, जो given original आपका total था, pick a valid committee. पिक अ वैलिड कमेटी, पिक अ वैलिड कमेटी, एक वैलिड कमेटी आपने पिक करनी है, ठीक है। What is the probability that you will pick a valid committee? Answers in the chat window. What is the probability that you will pick a valid committee? Answers in the chat window. Probability that you will pick a valid committee would be 300 divided by total number of ways that you can pick a committee, which was 792. Which was 792. Okay. Now, if I ask you from 5 women and 7 men, pick a valid committee, what is the probability? What is the probability that it consists of 5 specific people? 5 specific people. 5 specific people. कौन? तारिक, मंसूर, अली, तान्या, आमना. No, ये 5 लोग हो सकते हैं. What is the probability? What is the probability that it consists of 5 specific people? Answers in the chat window. Bilal, you're saying 1/12 C5? Well, no. I'm just saying that from these 5 women and 7 men, you pick a valid committee. I'm not saying that you pick any committee. I'm not saying that you pick any committee. If you pick any committee, then it would be 1/792 to have these 5 specific people. But I'm saying that you picked a valid committee. अब मैंने आपको restrict कर दिया है कि आपने valid committee pick की है, and there are how many ways of picking a valid committee? There are only 300 ways of picking a valid committee. I have told you that you have picked a valid committee. I have told you that you have picked a valid committee. So from 5 men, 5 women and 7 men, you have picked a valid committee. What is the probability that this committee has these 5 specific people? And this would be 1/300. 1/300. And it is not 1/792. Not 1/792. What would be the question for this answer 1/792? ये होता कि आपके पास 5 women and 7 men है, उसमें से आपने एक कमेटी पिक की. हमें नहीं पता, उसमें हो सकता है 5 के 5 men आ जाए, हो सकता है 4 men 1 woman आ जाए, कोई भी आ सकता है उसके अंदर. 792 different ways of picking any man, any woman in a committee of 5. तो 12 choose 5 which is 792, वो पिक करने में हमने कोई रिस्ट्रिक्शन नहीं डाली हुई. हमने ये नहीं कहा कि आपने 3 men और 2 women करने, हमने ये भी नहीं कहा कि आपने 3 men और 2 women करने such that 2 fighting men are not together. हमने तो उनमें से कुछ भी नहीं कहा. हमने 1/792 का मतलब है बस आपने एक कमेटी पिक करनी है. What is the chance that it would be one specific committee जिनका नाम आप ले लेंगे? Okay. Now, I'm going to ask one more question here, and then maybe a couple more. Okay. So from 5 women and 7 men, the original group, pick a committee of 2 women and 3 men. मैं ये नहीं बता रहा हूं कि आपको कि ये वैलिड कमेटी है, हो सकता है दोनों फाइटर मैन इसके अंदर आ जाए. I'm just saying that pick a committee of 2 women and 3 men. Okay? और ये हमने ऊपर कैलकुलेट किया था. Pick a committee of 5 with 2 women and 3 men. ये there were 350 ways of doing that. वैलिड कमेटी पिक करने के कि ऐसी कमेटी पिक करें जिसमें 2 women and 3 men हो, जिसमें 2 वो फाइटर भी इकट्ठे ना हो, तो वो थोड़ा सा और कम हो जाता है. हमने और रिस्ट्रिक्ट कर दिया. So only 300, not 350 but 300. अगर आपने 2 women 3 men पिक करने, 350 ways of doing that. If you have to pick 2 women and 3 men such that the 2 fighting men are not together, then there are 300 ways of doing that. Okay. So now I'm saying that from 5 women and 7 men, you pick a committee of 2 women and 3 men. 2 women and 3 men. There are 350 ways of doing it. Okay. Now, my question is that what is the probability that it is a valid committee? Answers in the chat window. What is the probability that it is a valid committee? Answers in the chat window. देखें कितने वेज हैं कि कमेटी वैलिड होती है. 300 ways. कितने ways हैं कि you pick 2 women and 3 men? 350 ways. So this would be 300 out of 350. So many ways of picking a valid committee out of a committee of 2 women and 3 men. जो 350 ways से हो सकती है, इससे ज्यादा से हो ही नहीं सकती. So the probability of picking that is going to be 300 out of 350. 350 में से 300 ways हैं जो जिसमें हमारा वाला आंसर आता है. Okay. So we are getting close to the conclusion of this question. Again, well, this question will tell you, all the various different counting. इसमें counting principle भी आ रहा है, permutations अभी तक नहीं आई हैं, combinations आई हैं, picking subset आ रहे हैं, how to leave out some people उस तरह से आ रहा है, probability की calculations आ रही हैं. So again, I'm going to ask this question from 5 women and 7 men, our original group. Okay, pick a total of 5 people, and there were 792 ways of doing that. 12 choose 5. 12 choose 5. Okay, pick a total of 5 people. We don't know whether all of them are men, all of them are women, or whatever is the mix. Okay, I am going to ask this question: what is the probability? What is the probability these people consist of 2 women and 3 men? तो दोनों फाइटर भी आ सकते हैं इसके अंदर. मैं सिर्फ ये कह रहा हूं 2 women and 3 men आ जाएं. What is the probability of that? What is the probability of that? 2 women and 3 men आ जाएं. So the number of ways of picking 2 women and 3 men is 350, including the fighter वाली जो सिचुएशन है वो भी इसमें आ जाती है. दोनों फाइटर भी आ सकते हैं. Out of a total of 792. Out of a total of 792. Okay. Now, finally, if I ask you that from this original committee, pick a committee of 5 people, what is the probability? What is the probability that it is a valid committee? What is the probability that it is a valid committee? Answers in the chat window. Pick 5 people. Probability they form a valid committee. What is the probability they form a valid committee? Well, there are 300 ways of making a valid committee out of a total of 792 ways of picking 5 people, any 5 people out of the total group. Okay. So I'm going to just conclude this question here. इससे ज़्यादा और इसके बारे में कुछ नहीं कहना. So this should tell you, pretty much everything about counting. I would refer you to the generalized antenna problem. Remember, हमने antenna problem जो है वो last lecture के अंदर किया था, पहले lecture में. If you have not attended that lecture, please go ahead and watch the video. The video, by the way, is available on YouTube channel. उसका link जो है वो हमने LMS में भी डाल दिया. So anyone was able to watch the video, and did anyone check that whether you can access the video? कोई confirm करेगा? Yes. Okay, if few people have done that, then that means everyone should be able to do that. So in that first lecture, I'm going to upload the second lecture today, but in the first lecture, we talked about an antenna problem where you have 2 good antennas, 2 broken antennas, and you put those antennas on a device. Now, you can generalize that. You have a large number of antennas, out of which some of those antennas are broken. What is the probability that the device would be working? I think I would suggest you to take a look at the notes that I'm going to upload right after the class. Okay. So I'm not going to spend any more time on that. There is one more counting method that I'm going to cover. It's a generalization of combinations and permutations. Okay? And it is called multinomial law. Multinomial law. Okay, it's a generalization of combinations and permutations. Okay. So here I'm going to say that you consider a set of n distinct objects and distinct objects. So out of these n distinct objects, ये आपके पास n distinct objects हैं, ये मैंने बना दी हैं, बहुत सारी ऑब्जेक्ट्स हैं, ये n distinct objects हैं. इनमें से अब हमने ग्रुपिंग करनी है, और ग्रुपिंग हमें पता है कि combinations tells us कि if you have a big number of objects out of which you have to pick a smaller subset, तो वो n choose r से आप pick कर सकते हैं. But what if I have to make a group from a large number of objects? I have to make a group जिसमें एक ग्रुप जो है वो उसमें 4 लोग हों, फिर एक और ग्रुप हो जिसमें 3 लोग हों, फिर एक और ग्रुप हो जिसमें 2 लोग हों, एक और ग्रुप हो जिसमें 5 लोग हों. So what if I need to make multiple groups? So divide into r groups of sizes n1 n2 ... up to nr, which means कि पहले ग्रुप के अंदर n1 लोग होंगे, दूसरे ग्रुप के अंदर n2 होंगे, and so on and so forth, और ये आखिरी वाला जो ग्रुप है इसके अंदर nr लोग होंगे, such that n1 plus n2 plus so on up to nr, this is equal to n. इसको ऐसे भी लिखते हैं कि summation of ni summed over all I going from 1 to r, this is equal to n. I going from 1 to r, summation of all ni is equal to n. So that means ये सारे ये जो आपने ग्रुप्स बनाए हुए हैं, ये n1 n2 all the way up to nr, इन सबको आप ऐड करेंगे तो टोटल नंबर आपका पूरा, किसी को छोड़ नहीं देना है आपने. ठीक है. Now I am asking, ये you will realize that this is a problem of combinations, but a bit more generalized. Combinations के अंदर हम सिर्फ 2 ही ग्रुप्स बनाते थे, यहाँ पे आप r ग्रुप्स बना रहे हैं. In the combinations, you will pick a smaller committee out of n objects. You will pick a committee of r objects. ठीक है, और बाकी n minus r छोड़ देते थे. ठीक है, so 2 groups. Here you have more than 2 groups. Here you have r groups. ठीक है, so how many groups are there? R groups. Okay. So number of ways of picking n1 guys out of total of n guys. So n choose n1 ways of picking n1 guys out of a total of n guys, out of n. Okay. Now out of those n, I have already picked n1. So n minus n1 जो रह गए हैं, अब उनमें से आपने n2 पिक करने हैं. n2 ways of picking n2 guys out of the remaining n minus n-1, n minus n1. ठीक है, अब ये आपने n2 भी पिक कर लिया. अब आपके पास कितने रह गए? अब आपके पास रह गए n minus n1 minus n2, ये रह गए हैं. अब उसमें से आपने n3 पिक करना है. So many number of ways of picking n3 guys out of a total of n minus n1 minus n2 and so on and so forth. ये चलता जाएगा. ठीक है, so many ways of picking n1 guys, so many ways of picking n2 given that you have picked n1, and so many ways of picking n3, etc. ठीक है, so what is the total number of ways? Basic counting principle, and the basic counting principle tells us कि इसको multiply कर दें आपस में. ठीक है, number of ways of picking n1 guys, number of ways of picking, पहला एक्सपेरिमेंट, फिर दूसरा एक्सपेरिमेंट, तीसरा एक्सपेरिमेंट, इन सब की नंबर ऑफ आउटकम्स को मल्टीप्लाई कर दें. सो यू मल्टीप्लाई दोस, ऑल ऑफ दोस टुगेदर. n choose n1 multiplied by n minus n1 choose n2 multiplied by n minus n1 minus n2 choose n3 and so on and so on. ठीक है, so इसको सॉल्व अगर करें, इसको सॉल्व करें अगर, तो हमारे पास becomes very interesting. So n choose n1 is n factorial over n1 factorial into n minus n1 factorial. ठीक है, ये पहले वाले को मैंने लिख दिया. दूसरा वाला क्या है? दूसरा वाला है n minus n1 factorial n2 factorial और n minus n1 minus n2 factorial. ठीक है. The interesting thing which is happening here is कि ये n minus n1 factorial और n minus n1 factorial ये क्रॉस हो जाते हैं. इसी तरह ये वाला अगले वाले के साथ क्रॉस हो जाए, and so on and so forth. ये सब क्रॉस होते जाएंगे. At the end of the day, you will be left with n factorial here and n1 factorial here, n2 factorial here, n3 factorial here, nr factorial here. Now, by the way, you may have realized, ये शायद आपने नोट किया हो कि permutations में एक इस तरह की चीज आई थी, ठीक है? But this is not permutations. This is a different. The answer is the same. The mathematical answer is the same, but the concept is different. Why? कि इसमें से हमने ये किया है कि n ऑब्जेक्ट्स में से हमने उसको डिवाइड किया है r ग्रुप्स में. पहले ग्रुप में n1 टाइप के लोग हैं, दूसरे में n2, तीसरे में n3 and then n4. But these were all distinct people. These were all distinct people. All n of these were distinct people. Permutations में जहां पे हमारे पास ऑब्जेक्ट्स रिपीट होती थी, वहां पे भी इसी तरह से सॉल्व करते थे. Although कि यहाँ पे n1 plus n2 plus n3 all the way up to nr, इन सबको अगर सम करें तो आपके पास n आना चाहिए. परम्यूटेशंस के अंदर ऐसी नेसेसरी ऐसी चीज नहीं थी. So if you think about it, कि if you have n1 is equal to 1, n2 is equal to 1, n3 is equal to 1, nr is equal to 1, so it's really the permutation of n factorial people. अगर ये n1, n2, n3, n4 all the way up to nr ये सब के सब 1 हो जाते हैं, इसका मतलब है मेरे पास एक n लोगों का ग्रुप है, उनमें से एक और एक और एक और एक और एक और एक, इन सबको मैंने अलग-अलग करना है. इतने मैंने n ग्रुप्स बना देने हैं. हर ग्रुप में एक ही बंदा है, हर ग्रुप में एक ही पर्सन है. एंड देन the number of ways of making those groups is n factorial, which is equal to the number of permutations of arranging n people. I'll give you a very quick example before moving forward. Very quick example. So this example is about 10 police officers. 10 police officers. Okay. Divide into 3 groups. Divide into 3 groups. 3 groups में उनको divide करना है, ठीक है? 5 for patrolling, 3 for station, 3 को station पे छोड़ देना है, and 2 for rescue, 2 लोगों को rescue के लिए. So how many number of ways, number of divisions? So number of divisions possible is 10 factorial by 5 factorial, 3 factorial, 2 factorial, and we are done. This is 2520. We are done here. I will give you another example which will tell you, something very interesting to note is, let's say you have 10 people. 10 people. Again, police officers nahi hai, 10 general people. Select 2 of them. Select 2 of them. Okay? And number of ways kitne honge iske? Number of ways of selecting 2 people out of 10. Sabko pata hai. Selecting 2 people out of 10. How many number of ways? Answers in the chat window. Mustansir says 10. Choose 2. Anyone else? 10 people. Select 2 of them. How many ways of selecting 2 guys out of 10? How many ways of selecting 2 guys out of 10? This is simple combination. 10 लोगों में से आपने 2 लोग पिक करने हैं यार, कितना? Says 10 choose 2. 10 choose 2. 10 choose 2. And this turns out to be 45. This is exactly the same as dividing these 10 people. Dividing these 10 people into 2 groups. One of size 2 and one of size 8. So multinomial law यहाँ पे लगता है कि 10 लोग हैं, उसमें से 2 को आपने एक ग्रुप में डाल दिया और बाकी 1, 2, 3, 4, 5, 6, 7, 8 8 को एक ग्रुप में डाल दिया. So these two groups, इस ग्रुप के अंदर आपने डाल दिया, and this is the number of ways of grouping. How many different groupings are possible? number of groupings that are possible is this. Okay, now I'm going to modify this question a little bit and you will see कि आंसर कैसे चेंज होता है. ठीक है, आंसर ऐसे चेंज होता है कि लेट्स से यही 10 लोग हैं, लेट्स से यही 10 लोग हैं, 10 people, out of these 10 people, ठीक है, again select two of them, one for president and one for vice president, and one for vice president. Okay. Now let's say if you have picked two people, Ahsan and Tariq. So in the first case, I don't care कि Ahsan और Tariq में Ahsan पहले आ जाए या Tariq बाद में आ जाए या Tariq पहले आ जाए Ahsan बाद में आ जाए, because Ahsan and Tariq they form a group. So there are 45 different ways of doing that. But now I'm saying that if you are picking Ahsan and Tariq, one of them is for president, the other is for vice president. So if Ahsan is president and Tariq is vice president, this is different from saying that Tariq is president and Ahsan is vice president. So दो different ways हो जाते हैं इसके अंदर. ठीक है. So now एक तो possibility ये है कि मैं ये ऊपर वाला जो आंसर है उसको 2 factorial से multiply कर दूं, which is the number of ways of arranging those two people here. Okay. उन दो लोगों में से एक को आपने प्रेसिडेंट बनाना है, एक को वाइस प्रेसिडेंट बनाना है, तो 2 फैक्टोरियल डिफरेंट वेज में आप उनको अरेंज कर सकते हैं, परम्यूटेशन से मल्टीप्लाई कर दें. देयर इज अनदर वे ऑफ लुकिंग एट द सेम थिंग इज कि नंबर ऑफ वेज ऐसे हैं कि अब आपने 3 ग्रुप्स बना देने. एक 8 लोगों का ग्रुप है जिनको कुछ भी नहीं करना, और एक ग्रुप एक पर्सन का है जिसको प्रेसिडेंट बनाना है, एक और ग्रुप 1 पर्सन का है जिसको वाइस प्रेसिडेंट बनाना है. सो दिस इज नंबर ऑफ वेज इज 10 फैक्टोरियल ओवर 8 फैक्टोरियल जिनको छोड़ देना है, और 1 फैक्टोरियल एक ग्रुप बनाना है, एक और 1 फैक्टोरियल एक और ग्रुप बनाना है. ठीक है, एक प्रेसिडेंट का ग्रुप है, एक वाइस प्रेसिडेंट का ग्रुप है, एंड दिस विल टर्न आउट टू बी 90, व्हिच इज द सेम एज इफ यू मल्टीप्लाई 45 बाय 2 फैक्टोरियल. दोनों एक ही बात है, चाहे ऐसे देख लें उसको और चाहे ऐसे देख लें. तो नोटेशन दैट वी यूज, notation for multinomial law is if you have n distinct objects, इनको ग्रुप्स में आपने डिवाइड करना है. So multinomial law की नोटेशन ये है, number of groupings of n people or n objects. I should use objects here. N objects into groups of sizes n1, n2, ... up to nr, such that summation I is equal to 1 to r and I is equal to n. उन सबको ऐड अप कर दें तो ये n के बराबर होना चाहिए. So number of groupings कितनी पॉसिबल होती हैं वो भी हमने ऊपर देखा कि n फैक्टोरियल ओवर n1 फैक्टोरियल इंटू n2 फैक्टोरियल ... up to nr फैक्टोरियल. इसको ऐसे भी लिखते हैं, दिस इज रिटन एज n में से आपने बिल्कुल कॉम्बिनेशन जैसे होती है ना, n1 n2 n3 ... up to nr. कॉम्बिनेशंस में सिर्फ एक ही चीज लिखते हैं और दूसरी जो है implicit होती है. So you can see that this is a generalization of combinations. Great. I'm going to switch gears now. Any questions before we do that? Any questions? ये अभी तक जो है ना ये basic stuff ही repeat हो रहा है from a basic probability course. If you have taken that recently, then that's fine. You probably would have remembered that. लेकिन अगर कुछ टाइम हो गया, कुछ चीजें भूल गई हैं, तो it's not difficult. It's pretty simple stuff. We will upload the notes. Please make sure to take a look at those before we move forward with the rest of the material. क्योंकि हम ये बार-बार ये पीछे आके जो है वो repeat नहीं करेंगे. The videos obviously will be available on YouTube. आप कभी भी उनको पीछे जाकर दोबारा देख सकते हैं. but yeah, any question before we move forward? Now I'm going to move forward with some basic definitions जहाँ पे हम probability and sample space उसका जिक्र करते हैं. Some definitions. So first definition is about a random experiment. Random experiment. What is a random experiment? Random experiment क्या होता है? Random experiment is the one in which the outcome is not predetermined. आउटकम को आपको पहले से पता नहीं होता. सो फॉर एग्जांपल डाइस रोल करें, नहीं पता क्या आएगा, हमें नहीं पता क्या आएगा. सो रोलिंग अ डाइस इज अ रैंडम एक्सपेरिमेंट. इफ यू हैव ए डेक ऑफ प्लेइंग कार्ड्स, 52 प्लेइंग कार्ड्स अगर आपने वो देखे हो, उसमें से एक कार्ड पिक करना है आपने रैंडमली. एक कार्ड पिक करना है, कुछ पता नहीं है कौन सा कार्ड आएगा. इट कुड बी एनी वन ऑफ दोस 52 कार्ड्स. Any one of those 52 cards. So picking a card out of a deck of 52 cards is a random experiment. If you pick 5 cards out of a deck of 52 cards, it's still a random experiment. ये फिर भी एक random experiment है. Okay? So when you perform a random experiment, there is possibility that you will get one of the possible outcomes. When you perform a random experiment, you get outcomes. और उनको हम क्या कहते हैं? Sample points. So for example, if you roll a dice, there are 6 sample points or 6 outcomes. If you roll a dice, there are 6 outcomes. या 1 आएगा, या 2, 3, 4, 5, 6, इनमें से कोई आएगा. There are 6 possible outcomes or 6 sample points. Same thing, outcome, sample point, एक ही चीज है. Okay. Now, इनको क्यों sample point कहते हैं? Because I define something called sample space. What is sample space? This is the set of all possible outcomes. So, for example, if you roll a dice, the set of 1, 2, 3, एक सेट है जिसके 6 एलिमेंट्स हैं. वो पूरी की पूरी सैंपल स्पेस होगी उस एक्सपेरिमेंट की. A different experiment will have a different sample space. उसकी अपनी सैंपल स्पेस होगी. इसको डिनोट करते हैं ओमेगा या एस. जनरली ऐसे लिखते हैं, हम जिस मर्जी से करते हैं, बट in most books you will see that they will denote it with s or omega. So what that means is कि S is a set जिसके अंदर वो सारे एलिमेंट्स होते हैं जो आपके आउटकम्स हो सकते हैं. S के बाहर की कोई चीज नहीं आएगी. सो डाइस रोल करेंगे, कभी 7 नहीं आएगा, कभी 9 नहीं आएगा. 1 से लेके 6 तक इनमें से कोई आएगा. All of those points are part of the sample space. All possible outcomes, जितनी भी possible outcomes हैं वो हमने sample space के अंदर डाल देंगे. So that means that one of the outcomes in the sample space will occur. Exactly one outcome in the sample space will occur. एक से ज्यादा नहीं होंगी, एक ही आउटकम अकर करेगी. ठीक है? Very important to realize that. And I'm sure many of you probably already realize that. I'm just emphasizing it. It is important to make sure that we understand that जितने भी आपकी ये sample space है, if you have a sample space, ये इस तरह की एक sample space है, या ओमेगा कह दें या s कह दें, उसके अंदर sample points हैं आपके पास. Let's say एक ये sample point है, 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 और एक ये sample point है, एक ये sample point है. Out of these sample points, exactly one of these occur. Dice roll करेंगे तो एक ही नंबर आएगा. दो नंबर simultaneously नहीं आ सकते. ठीक है? So we say that these outcomes are mutually exclusive. They do not happen simultaneously. इनको हम कहते हैं ये mutually exclusive है. These outcomes are mutually exclusive. Exactly one of these will occur. ये भी नहीं हो सकता कि इनमें से कोई भी ना अकर करे. एक अकर जरूर करेगी और exactly एक ही अकर करेगी. So if you recall from the set theory कि एक जो set होता है उसके अंदर elements होते हैं, so these outcomes are the elements of that set. I define something which is called an event. Event क्या चीज है? Event is a subset of S. Event is a subset of S, जिसके अंदर some outcomes हो सकती हैं. ये भी हो सकता है एक event के अंदर zero outcome, एक event के अंदर zero outcome भी हो सकती है, which means कि that event is never going to occur. जिसके अंदर zero outcome हो वो event कभी occur ही नहीं करेगा. ठीक है. एक event ऐसा भी हो सकता है जिसमें सारी की सारी outcomes हो, वो पूरी की पूरी sample space को encompass करता है. That event will be guaranteed to occur. वो लाजमी occur करेगा. ठीक है. So event is simply a subset of S. Simply a subset of S. So for example, you can have an event A. You can have an event A, or you can have an event. ये मैं थोड़ा सा overlapping भी बना रहा हूँ. You can have an event B, and you can also have an event C. ये green में जो बना C. ये तीन मैंने events यहाँ पे show कर दिए. ये तीन यहाँ पे events मैंने show कर दिए. So event A will contain how many points? 4 points. इन 4 points में से, इन 4 outcomes में से, इन 4 sample points में से अगर कोई सा भी occur कर जाए हम कहेंगे कि A occur किया है. So A occurs if any of the sample points, any of the outcomes or sample point contained in A occurs. Remember, A की outcome आनी है. अगर ये वाली outcome आती है, जैसे कि ये वाली outcome आती है, let me use some different color. If this outcome happens, ये जो outcome जिसको मैंने arrow से show किया हुआ है, if this outcome happens, let me ask you this question. Does A occur? Yes or no? Answer in the chat window. Does A occur? If this brown arrow के साथ जो हमने outcome बताई है, if वो वाली outcome occurs, हमें पता है कि exactly A की outcome occur करेगी. If I tell you that this outcome occurs, then does A occur? A does not occur. A does not occur. Why? Because that outcome is not contained in A. On you have a different point of view. You want to say why? On Ahmed?
सर ये जिस तरह आपने कहा कि अगर एक जैसे मैंने इससे किया क्योंकि बी के अंदर वो आउटकम है, ठीक है, तो पूरा बी अकर हुआ है और बी के अंदर ए का एक और आउटकम है, तो इस तरह फिर ए का भी अकर
नहीं, लेकिन वो आउटकम ए में तो नहीं है यार.
ओके ठीक है, आगे समझ.
ए एक और इवेंट है, बी एक और इवेंट है, सी अपना एक और इवेंट है. These are 3 separate events. B अकर करता है या नहीं करता? Yes or no? Yes or no? Does B occur or not? If this brown outcome occurs, does B occur or not? B occurs. Yes. Does C occur or not? C does not occur. So एक उसकी एग्जांपल आपको और दे देते हैं. एग्जांपल ऐसे दे देते हैं कि लेट्स से यू रोल अ डाइस, तो आपके पास नंबर्स आएंगे 1 2 3 4 5 6. ठीक है. एक इवेंट आपके पास ये ए आ जाता है. ठीक है. एक ये इवेंट आपके पास बी आ जाता है और एक ये इवेंट आपके पास सी आ जाता है. So this brown guy is A, the red guy is B, and the blue guy is C. So अब मैं कहता हूं कि डाइस रोल करते हैं और 5 आ जाता है. डाइस के ऊपर 5 आ गया. Does A occur or not? A occur or not? No, A does not occur because A के अंदर वो 5 है ही नहीं. Although कि B के अंदर है और B A के साथ थोड़ा ओवरलैप भी कर रहा है, लेकिन B एक अपना अलग इवेंट है, A अपना अलग इवेंट है. So 5 अगर आता है तो A नहीं अकर करेगा. 5 अगर आता है तो B अकर करेगा. 5 अगर आता है तो C भी अकर करेगा. See, if 5 occurs, ये outcome 5 आ गई आपके पास, then B occurs, also C occurs. Now this is interesting to know कि आउटकम तो हमने कहा था कि एक ही आएगी एग्जैक्टली, एक से ज्यादा नहीं आ सकती, लेकिन इवेंट्स एक से ज्यादा आकर कर सकते हैं. बी देखें 5 अगर आता है तो बी भी अकर कर रहा है और सी भी अकर कर रहा है. व्हाई? बिकॉज both of these events they contain this point. Both of these events they contain this point. ठीक है? All right. So I'm going to talk about events which are called mutually exclusive. Mutually exclusive events. Mutually exclusive events. Mutually exclusive events are the ones which never occur together. Exclude कर देते हैं एक दूसरे को. If you look at the outcomes, each outcome is also an event. Each outcome can also be regarded as an event. वो एक ऐसा event है जिसके अंदर एक ही outcome है. जैसे यहाँ पर A के अंदर 4 outcomes थी, B के अंदर 1 2 3 4 5 outcomes थी, C के अंदर 3 outcomes थी, but each outcome itself can be regarded as an event. Each outcome itself can be regarded as an event. And since these outcomes do not happen simultaneously, all those events जो एक ही outcome को include करते हैं, all those events are going to be mutually exclusive. Mutually exclusive. In this example, ये वाली जो example है, the one that I am circling right now, और ये जिसपे मैंने arrow लगा दिया बड़ा सा, you have 3 events A, B, and C. You have 3 events A, B, and C. Let me ask you this question: are A and B mutually exclusive? Yes or no? They are not. Are B and C mutually exclusive? Yes or no? ये भी no. Are A and C mutually exclusive? ये पहले किसी ने B और C को भी mutually exclusive कह दिया था. भाई B और C वो ऊपर चला गया, मैं देख नहीं सकता किसने कहा था. So B और C mutually exclusive नहीं है. Why? Because there are events, there are outcomes which are common to B and C. ऐसा हो सकता है कि ये वाली आउटकम आए तो बी भी अकर कर गया और सी भी अकर कर गया. ठीक है, 2 इवेंट साइमल्टेनियसली हो सकते हैं, 2 आउटकम्स साइमल्टेनियसली नहीं हो सकते. ठीक है, वेरी इंपॉर्टेंट टू अंडरस्टैंड दैट. म्यूचुअली एक्सक्लूसिव इवेंट्स आर द वंस which do not are the ones which do not occur simultaneously. Which do not occur simultaneously. ये म्यूचुअली एक्सक्लूसिव इवेंट्स होती हैं. जो आउटकम्स होती हैं, दे आर ऑलवेज म्यूचुअली एक्सक्लूसिव. आउटकम्स आर ऑलवेज म्यूचुअली एक्सक्लूसिव. क्यों? क्योंकि वो एक ही सैंपल पॉइंट होता है. वो हमेशा हमें पता है कि उनमें से एक ही अकर करेगा. दे आर ऑलवेज म्यूचुअली एक्सक्लूसिव. Now, I will ask one more question by defining something which is called mutually exclusive. हो गया है collectively exhaustive. Collectively exhaustive events. What are collectively exhaustive events? Collectively exhaustive events are the ones जिनका यूनियन अगर लें, union of these events is the complete sample space. उनका यूनियन लें तो पूरी की पूरी सैंपल स्पेस आ जाएगी. Let me ask you this question: are A and B in this figure? Are A and B in this figure collectively exhaustive? Yes or no? No. Are A, B, and C collectively exhaustive? A, B, and C are collectively exhaustive. यहां पे हम पूछते हैं, बल्कि पहले इसमें से पूछते हैं, are A and C collectively exhaustive? They are not. Okay, now we are going to ask questions about this second figure. ये वाली जो फिगर है, अब इसके बारे में सवाल पूछते हैं. Are A and B collectively exhaustive? No. are A and C collectively exhaustive? A and C are collectively exhaustive. क्यों? इन दोनों का यूनियन लेने सब कुछ कवर हो जाता है. B जो है, B अगर ना, B जो है वो हम ना भी कंसीडर करें, A and C collectively exhaust the entire sample space. Collectively exhaust the entire sample space. So A and B are collectively exhaustive. So are A, B, and C collectively exhaustive? Yes or no? A, B, and C. ऊपर वाली फिगर पे आते हैं. ऊपर वाली फिगर में सबने बताया था कि A and C are not collectively exhaustive. My question is, are A, B, and C collectively exhaustive? They are collectively exhaustive. Okay. Now the question is, are A and C mutually exclusive? Yes, great. सही जवाब आ रहे हैं सारे. इस सवाल में are A and C mutually exclusive? A and C mutually exclusive. So in the second figure, A and C are mutually exclusive as well as collectively exhaustive. इस फिगर के अंदर A and C are mutually exclusive as well as collectively exhaustive. ये एक स्पेशल टाइप होती है, कभी इसका जिक्र आएगा लेटर ऑन, तो ये हम उसकी बात करेंगे. कुछ एग्जांपल्स के बगैर we don't work without the examples. Yeah. So examples of sample space and events. Coin toss करते हैं. What is our sample space? The sample space consists of head and tail. Two outcomes, only two outcomes, and both of these outcomes equally likely. Both outcomes equally likely. Both outcomes equally likely. Dice roll करके देखते हैं. Dice roll. How many outcomes? Answer in the chat window. 6 outcomes. And the sample space is 1, 2, 3, 4, 5, 6. These are the 6 outcomes. And all 6 outcomes, equally likely. Most of the time we will see कि जब आप experiment करते हैं जो outcomes आती हैं ना, ये equally likely होती हैं, but not always. Most of the time they are, but not always. So important to remember that. Now एक और काम करते हैं कि हम अब 3 coins को toss कर देते हैं. Toss 3 coins. You have 3 coins and you toss 3 coins. Okay. How many points in the sample space? How many sample points in the sample space? Yes, 8 points in the sample space. 8. एक दो example दे दें sample points की in the chat window. 8 points in the sample space. Great. So sample space consists of H, T, and so on and so forth, all the way up to T. ठीक है, ये 8 होंगी टोटल. ये बेसिक काउंटिंग से भी कर सकते हैं कि कितनी होंगी. क्यों? पहले कॉइन के ऊपर 2 पॉसिबिलिटीज, दूसरे कॉइन के ऊपर 2 पॉसिबिलिटीज, तीसरे कॉइन के ऊपर भी 2 पॉसिबिलिटीज, टोटल 8 पॉसिबिलिटीज. So it's reasonable to say कि each of these outcomes is equally likely. 8 outcomes and equally likely. If they are equally likely, what is the probability of a specific outcome, HTH? What is the probability of that outcome happening? Answers in the chat window. It's going to be 1/8. It's reasonable to say that. Okay. Define event A. That you have exactly 2 heads. Exactly 2 heads. इसका मतलब क्या है? इसका मतलब है कि ए के अंदर इवेंट ए जो है इज अ सबसेट ऑफ द सैंपल स्पेस, और एक सेट का सबसेट जो होता है वो भी सेट ही होता है। सेट थ्योरी हमें ये बताती है कि एक सेट का अगर आप सबसेट लेते हैं तो वो भी सेट ही होता है। सो ए इज अ सेट which has all the outcomes which have exactly two heads. So it could be HHT, HTH and THH, या पहले पे टेल आ जाए, या दूसरे पे टेल आ जाए, या तीसरे पे टेल आ जाए, बाकी दोनों पे हेड। So what would be a reasonable number for the probability of A? Reasonable number for the probability of A. Probability of A happening is 3 outcomes out of 8. Since each of those are equally likely, so this is 3 out of 8. 3 out of 8. It's reasonable to assume that. No. हम ये किसी तरह प्रूफ भी कर सकते हैं rigorously, but for now we will say कि यार this looks reasonable to assume that. तो फर्स्ट कोर्स होगा प्रोबेबिलिटी का, which you guys might or might not have taken, या may or may not remember, उसमें ये चीज शायद प्रूव भी की हो। Okay, now very quickly I'm going to talk about another example, and the example is toss 2 coins. Toss 2 coins. How many sample points? How many sample points? 4 sample points. 4 sample points. Okay. Now let me define 2 events. Let me define 2 events. E is the event that first coin is head. So E का सेट जो होगा, उसके सेट में क्या होगा? E के सेट में you will have a HT और HH. ऐसे लिख दें, या कोई लोग इसको ऐसे भी लिखना पसंद करेंगे, HT HH, एक ही बात है, एक ही बात, HT and HH, HT and HH. Let me define the event F as second coin is head. Second coin is head. That means F is an event which can be written in the form of a set, and this would be second is head, so it could be TH or HH. Everyone is okay with that? जो पहले लिखा हुआ है वो फर्स्ट कॉइन की आउटकम है, जो दूसरा है वो सेकंड कॉइन की। Now I'm going to define something. Remember, events are sets. Events are sets. तो उसके ऊपर हम सारे सेट ऑपरेशंस कर सकते हैं। सेट्स का क्या हम करते हैं? सेट्स का यूनियन ले सकते हैं, सेट्स का कॉम्प्लीमेंट ले सकते हैं, सेट्स का इंटरसेक्शन ले सकते हैं। So everything that you can do with sets, set algebra आपको जिस चीज की इजाजत देता है, you can do with events. You can do with events. Why? Because events are the sets. Events are sets, nothing else. ये आपके सैंपल स्पेस के अंदर से ही आपने निकाले, events are the sets. So what is E union F? E union F. ये क्या सेट होगा? कि first coin is head and second coin is head. So when you say E union F, then I'm saying that E union F means either E or F or both. Either E or F or both. So either E occurs or F occurs or both occur. या इसको हम ऐसे भी कह सकते हैं कि at least one of them occur. At least one of them occur. For this example, toss 2 coins. If the first coin is head, then event E occurs. If the second coin is head, then F occurs. Then E union F, इसकी interpretation क्या है? इसकी interpretation ये है कि at least one head occurs. At least one head occurs. So if I tell you that toss 2 coins, what is the probability of at least one head? What is the probability of at least one head? So all you need to do is find E union F. और E union F जो है वो क्या होगा? आपके पास this set will have all the union elements which are going to be HT, HH and TH. TT is not going to be there. ये देखें TT जो इधर भी नहीं है, TT इधर भी नहीं है, so union में भी नहीं आएगा. यूनियन में भी नहीं आएगा. सो द प्रोबेबिलिटी ऑफ E union F is going to be 3 out of 4. 4 outcomes हैं equally likely, reasonable to assume that those are equally likely, and 3 out of 4. 3 out of 4 is the probability of E union F. I'm going to ask the question about E intersection F. E intersection F. पहले इसकी event की interpretation बताएं. What is the interpretation of this event? E is the event that the first coin is head, second coin is head, that's the event F. What is the interpretation of E intersection F? जैसे हमने E union F की interpretation बताई थी, at least one head occurs. What is the interpretation of E intersection F? Answers in the chat window. इसकी interpretation क्या होगी? What would be the interpretation of that? Tara, Rafe, Bilal, Mustansir. Bilal H तो है, ठीक है वो, लेकिन interpretation उसकी ये है कि both are heads. Both are heads. E occurs and F occurs. When you have an intersection of two sets, that means उनके common points आप ले लेते हैं. So that means कि E भी occur कर रहा है और F भी occur कर रहा है. If you have two sets E and F, so E intersection F is the intersection of these two. That means कि अगर इसके अंदर कोई outcome आ गई, इस shaded area के अंदर कोई outcome आ गई, which is the common intersection area between E and F, तो E भी occur करेगा, F भी occur करेगा, and that is what we want कि E and F both will occur. E union F के अंदर या E occur कर जाए या F occur कर जाए या दोनों occur कर जाए. So that means E union F के अंदर ये blue वाला सारा कुछ आएगा, ये blue वाला सारा कुछ E union F के अंदर आएगा, ठीक है. So E intersection F both are heads. So E intersection F, इसको अगर देखें ये सेट क्या बनेगा आपके पास, आपको ये वैसे इन सेट से भी नजर आ जाएगा कि हेड हेड कॉमन है इसमें, तो दिस वुड बी हेड हेड, और या इंटरप्रिटेशन से देख लें कि बोथ आर हेड, एंड द प्रोबेबिलिटी ऑफ E intersection F is going to be, answers in the chat window, 1/4. अच्छा, इसको ऐसे भी लिख देते हैं, प्रोबेबिलिटी ऑफ E and F together. बाज दफा वो ये इंटरसेक्शन का साइन नहीं लिखते. Many books will use this notation कि अगर ये इंटरसेक्शन का साइन नहीं है बीच में, इसका मतलब है कि इंटरसेक्शन ही हो रही है दोनों, E and F happening together. So this is going to be 1/4. 1/4. By the way, जो म्यूचुअली एक्सक्लूसिव इवेंट्स होते हैं, they do not occur simultaneously. ये आपका एक इवेंट है A और ये आपका इवेंट है B. A और B, nothing is common. A and B are mutually exclusive. ठीक है. If A occurs, B will certainly not occur. If B occurs, then A will certainly not occur. A will certainly not occur. So A और B mutually exclusive होते हैं. What is the probability of A and B happening together? That probability is going to be 0. That probability is going to be 0. So कुछ set operations हैं, those are given in the notes. ये notes जो है मैं अभी share कर लूँगा, आप kindly उसमें से जरूर देख लें इन set operations को. We are not going to go over the basic set theory जो शायद class 10 से पढ़ते हुए आ रहे हैं, या maybe even उससे पहले भी. So I'm just going to share those notes. उसमें से आप it's half page, उसको जरूर पढ़ लें. And next time we are going to cover the axioms of probability, and then union of events की generalization with few examples. ठीक है. Any questions before I finish the session? There is one.
सर मेरा जनरल क्वेश्चन है, आपका ये कोर्स स्प्रिंग में ऑफर होता है?
जी नहीं.
ओके.
जी बिलाल.
सर मेरे 2 क्वेश्चन थे. पहला क्वेश्चन ये था कि आगे चल के कोर्स में हम R सॉफ्टवेयर या किसी किस्म की प्रोग्रामिंग यूज करेंगे?
कोई प्रोग्रामिंग नहीं है इस कोर्स के अंदर.
ठीक हो गया. दूसरा क्वेश्चन ये था कि सर्कुलर परम्यूटेशन नाम की भी कोई चीज होती है, तो वो हम पढ़ेंगे, आगे चल के पढ़ेंगे या फिर वो पढ़नी
क्या चीज होती है?
circular permutation.
सर्कुलर परमुटेशन, मुझे पता नहीं है आप वो क्या चीज आप किसको रेफर कर रहे हैं। एक सर्कल के ऊपर हम लोगों को अरेंज कर सकते हैं, इस तरह का कोई प्रॉब्लम हो सकता है कि एक सर्कल के ऊपर आपने लोगों को अरेंज करना है, उसमें से कुछ कितनी वेज में आप अरेंज कर सकते हैं, बट दैट कैन बी सॉल्व्ड बाय यूजिंग द डेफिनेशन ऑफ परमुटेशन जो हमने की है। थोड़ी सी ट्रिक लगानी पड़ेगी उसके अंदर, एंड आई विल लीव दैट एज एन एक्सरसाइज, शायद कोई होमवर्क का प्रॉब्लम दे देंगे। ठीक है, कोई और क्वेश्चन? Any other question? कोई क्वेश्चन नहीं?
Sir,
जी
will we
जी।
have any quiz in the coming Sunday or Monday?
In the coming,
Sunday or Monday, because you said that we're going to have one every week.
we will have one every week. This week is an exception, and probably the last week will also be an exception. So otherwise, we will have a quiz every week, and most likely it's going to be on Sunday evening. क्योंकि मंडे को जो है वो 6 बजे से 9 बजे तक रात को क्लासेस रख दी है यूनिवर्सिटी ने।
जी जी।
So we don't know whether it would be suitable for everyone or not. And since there are, more than 100 students taking this course, it would be very hard to fit everyone's schedule. So Sunday is the safest option.
Sir, that makes sense. Thank you.
ठीक है, thank you. क्विज टाइमिंग जो है वो डिसाइड कर लेंगे, probably 6 बजे के करीब होगी, 5 बजे 6 बजे इस तरह, संडे आफ्टरनून को, समथिंग लाइक दैट। जी रिजवान।
सर मैं सिर्फ कंफ्यूज हुआ था, हमारे लेक्चर डेज जो हैं वो वेंसडे फ्राइडे हैं
जी
तो, लेकिन हमारा कोई संडे को हुआ करेगा।
जी जी, कोई संडे को हुआ करेगा।
ओके
जी, आउटलाइन में भी लिखा है हमने और पहले लेक्चर में भी बता दिया।
एक्चुअली मैंने मिस कर दिया था, पहला मेरी एनरोलमेंट नहीं हुई थी उस वक्त।
चलिए कोई बात नहीं, आप पता चल गया। So it would not be possible to find any other time, और क्विज लेते लेते ऑनलाइन क्विज होगा तो ऑनलाइन क्विज में आधा घंटे लग ही जाता है, अगर 20 मिनट का 15 मिनट का भी क्विज हो तो आधा घंटा फिर भी लग जाता है। So it would not be wise to spend the class time for that. उसके लिए हमें अलग ही टाइम निकालना पड़ेगा। एंड लास्ट टाइम वो डिस्क्राइब के वो टाइम जो हम जस्टिफाई ऐसे करेंगे, वैसे जरूरत नहीं है जस्टिफाई करने की, सीख ही रहे हैं चीज, वैसे तो जस्टिफाई करने की जरूरत नहीं है, लेकिन अगर आपको जस्टिफिकेशन चाहिए उसकी तो हम मिड टर्म एग्जाम नहीं लेंगे, उसकी जगह पे इन लीव ऑफ दैट वी विल हैव दीस क्विज़ेस। ठीक है, I just wanted to ask, for the people who are still remaining here, कितने लोग हैं जिन्होंने मेरे साथ बेसिक प्रोबेबिलिटी वाला कोर्स लिया? Anyone? Nobody. कोई भी नहीं? हाँ उसामा, पोल नहीं कर सकते मंडे और संडे, ऊपर ही किसी ने कह दिया कि मंडे को क्लासेस हैं, सो इफ इवन अ सिंगल पर्सन हैज क्लासेस ऑन मंडे, संडे का हमें पता है, वी आर श्योर कि देयर आर गोइंग टू बी नो क्लासेस, या तो मंडे को जो है वो फिर क्लासेस के बाद करें, रात 10 बजे करें, बट आई डोंट थिंक के पीपल विल लाइक दैट, आई डोंट माइंड दैट, बट we have to make sure that everyone is is available at that time. Any other question? Okay, great. Then I'm going to stop the share here and close the session. We'll upload the video as soon as it is available on Zoom. And you should be able to see the video or share the video, whatever you want to do with it. Okay, great. Thank you. The office.